Hello. Today we're going to be doing some absolute masochisms here. Um, Mostly because we're going to be using pointers in C#. So we have this nice program here, and we want to basically not transform actually, we just want to obtain an array of a certain data of structs that is an array of structs. So I have this struct which has two data types. It has a string and it has an integer, and here I assigned it, and we want to sort of declare an array, which is exactly what I'm doing here, which is just of the integers and then loop through it. Here I print them. Now this program is very simple, and it's doing basically two main heap allocations, which are this, writing the array of the structs and then write the array of the integers. And when you do any sort of heap allocation in C#, the garbage collector is managing every bit of the memory for you. You don't need to do anything manually. And kind of the thing what we're going to do here is ask the question, what if you want though? What if you're feeling a bit confident that you can just do all these memory things yourself? And that's what we're going to do here. So we're going to do that with this array of ints. Can you do that with this? Yes. But a small limitation of how pointers work in C# is that you can't, some types are declared to be the property of the garbage collector. And as far as I know, at least, maybe there is some way, if you do hit me up, I'd be interested in that. You can't really just declare a pointer to them. So probably what you'd need to do here with that name is try to use some library or convert this string type to a C-like string type, which is just an array of characters, which is a bit hard to deal with. But doing that way you could, because chars are not inherently managed by the garbage collector. Okay, so let's actually start. So the first thing you need to do actually is not in your code, is in your project. So this is the I'll just exit this. This is your project configuration. Here you have the csproj file, and you're going to enter it. And here in the property group, we want to add allow and save blocks true. Doing that, we just immediately made a contact with the devil here, and we were able to write very, very interesting pointer things. Now, right here you can start putting pointers and using pointers, but you'd not get very far, because C# doesn't have malloc, and you kind of need malloc to do anything interesting with arrays and etc. So, besides doing that, we're actually going to use a namespace here, which is the system runtime interrupt services namespace. Using system runtime interrupt services. And what this namespace is going to give us is giving us malloc, giving us free, probably other things that you can use to interact with your pointers. And by that point you can actually start. So I just want to write a pointer. What do? Well, I go here to a piece of my code, and I have to create an unsafe block. I can do that by just typing unsafe, and then I can write my dangerous code here. What you can also do is, if you have a function like this, you can actually put unsafe before the return type, and then the program will understand that you're writing unsafe code here. Just to be clear, just because the code is unsafe doesn't mean the garbage collector won't touch it. The garbage collector won't touch things that were declared as pointers by you or were fixed by you in that way. But you can still write normal C# code here and kind of mix things together and to be alright. Okay, so we're going to try to convert that to a pointer and otherwise maintain our application mostly the same. So I'm going to declare this a pointer. And here you're going to see the syntax very similar to C with the int with the pointer. and then go native memory alloc, and here we need to put the size of our array. Now we know the size of our array, it's 4 integers, but this is the, just like see, it's the amount in bytes, so we do 4 times size of and that's our array created. Can delete this, and now we're gonna just put those 2 things inside it, so they're referencing the same type. If you put this thing inside here and then put the other thing outside, it's not going to know. The types are declaring the unsafe code are kind of stuck to the unsafe block. I mean, it's a code block like any other. Okay, that will work actually. Well, not the function that, but that allocation here will work. You're writing like this, like if it was just an array, the C# will understand what you're doing. But I mean, if you also feel like you can also write it as a pointer, so we do not the asterisk here, but ID array, and now that's just a reference to the first element of the pointer, so we sum the k through iterate over it. That will also work. I'm gonna do that here just to see. And now the only thing that we need to change is how our method, how our function here is interpreting that pointer, because right now, probably this because I was testing before, but I mean, a priori in the old program you have this being an array here, and you just kind of change it to a pointer, just like it was. And again, you don't need to do anything after that because the C# will understand this thing. So I mean, if you run a program like this, it will work. Run. But, we're not done here, because what is the point of having manually memory management if you don't manage how that memory is freed? So, to finish with our business here, we just do native memory, which is the same method that gave you malloc, and just do free, and then our pointer. And then our pointer will be free. Run the application again, just so you see that we didn't break anything by doing that. Anyway, so that's kind of what I wanted to show in this video. This is a very basic example of how we can do manual memory management in C#. Just the fact that it's possible, it's very interesting. It's a very flexible language, though. Again, I think most people don't do that at all, and most people probably shouldn't. This is more out of curiosity than anything, really. There is a lot of, naturally programming things in C and C++ and languages that have manual memory management, they are much more bug prone because of that. But in C# you got some extra problems, like the fact that, as I said, for example, the string types and a lot of objects that you use from the libraries you're using are probably just going to be intrinsically managed by the garbage collector and going to have problems using them. But use this, put this in your toolkit as a feature of the language you can, use if you ever come to need it. Thanks for watching.